Hello students, today we are going to solve one question that is basically based on the concepts. The concept of insulation and conduction at various points in our day-to-day life where we observe all these things. So let's get started with the question. Here the question is divided into 4 subparts, and in each subpart they have asked us a question. In that we have to answer on the basis of the concept which we have learned in the previous classes. So the A subpart of our question says, a comb runs through one's dry hair, attracts small bits of paper. Why? What happens if the hair is wet or if it's a rainy day? Remember, a paper does not conduct electricity. So we are having two cases over here. One is dry hair and other one is wet hair. In case of dry hair, we observe that the comb run through it attracts bits of paper, whereas in the case of wet hairs, papers aren't attracted, or they are asking what happens. So what happens to the bits of paper in this case? In this case, it's 100% sure that paper gets attracted. Paper gets attracted. Now the thing which they reminded us is that, remember, a paper does not conduct electricity. Paper is a insulator. Paper do not conduct any electricity. Okay, then how is it possible? First thing, when our comb runs through our dry hair, in the dryness there is roughness in the hair. Dry hair symbolizes roughness in the hair, and due to this roughness, when comb strikes the hair, they will produce the frictional forces. These are hair strands, okay, and this is our comb. When we run it through these hair strands, there will be friction between these two. Comb and dry hair will feel friction. Due to this friction, the charges will start to accumulate on the comb, on the plastic comb. Like plastic comb itself is not a conductor. This comb itself is not a conductor. It's also a insulator. And in the first chapter we have read that on insulator, wherever charge goes, struck there only. The charge does not move in an insulator. Okay, so the charge, if accumulated over point A, here point A will stay at point A forever. So these will start accumulating charges. Now this comb is brought near the bits of paper, and this paper gets polarized due to the charge present on the comb. These bits of paper starts getting polarized. Okay, they will this comb and the bits of paper both together will form a dipole kind of thing. It's not exactly dipole, but it will be, one will be in the negative charge and another one will be in the positive charge. Okay, now when we see the case of a wet hair, wet hairs are basically smooth. So when we run a comb from these smooth hairs, there is no friction generated and hence no charge is generated on the comb, and therefore they will not, a comb which is run through the wet hair will not attract the bits of paper. Now we will see the solution. This is the explanation how you have to deal with such a question. Now we will see the solution here. This is because the comb gets charged by friction, okay, and the molecules in the paper get polarized by the charged comb, resulting in a net force of attraction. If the hair is wet or if it is rainy day, friction between hair and the comb reduces. The comb does not get charged and thus it will not attract small bits of paper. Okay, so moving to the next one, subset B. Ordinary rubber is an insulator, but special rubber tires of aircraft are made slightly conducting. Why is this necessary? So first thing we need to know what's an aircraft. Aircraft are the airplanes, helicopters and other rockets, everything you see which fly, right? So how much do you think they have weight in them? They are highly they have a lot of weight, highly heavy crafts or vehicles which tend to like fly against the gravity, fly against the gravity. Now when they are running on the road or when they are climbing up or climbing down, like taking off, at that position what exactly happens? The force from the aircraft, on the landing tires is too much, and first thing its own acceleration towards downward and second is the gravitational acceleration towards down. So two particular accelerations work on this aircraft at the position of taking off. When this thing comes down and touches the ground, at that point a lot of force is exerted on the road, on the path at which this aircraft will land. So now upon landing it will run for some time, like it have a lot of acceleration by flying, right? We know that one. It have lots of acceleration by flying and it cannot come to a sudden halt. There is no such possibility that this aircraft will show a sudden halt. Now this aircraft will keep on moving in the forward direction. In that forward direction the pilot will try to put brakes also. Due to the brake, this particular rubber is given here the brake. So there is a retarding force also, a force in this direction, a force in this direction, and due to the surface, rough surface, there is a frictional force, a retarding force, an accelerating force and a frictional force. Three different forces are acting on it, due to which combination of all the three on this particular tire of aircraft gives us heat, a lot of heat. If we think that this aircraft's tire is made up of a normal insulating rubber, as it is said, on an insulator the charges do not flow, the charges will not flow, instead they will stay at the same point. Wherever the charges are coming, they will stay, they will accumulate at the same point, and at a point the accumulation of charges will be so high that it will start generating heat and will burn the tire and hence can harm the aircraft and the many other people who are involved in the aircraft. So it is necessary to make this particular tire little insulating. So these charges which are accumulated here will start flowing in the whole tire and will conduct these charges to the earth also. The road on which it is traveling, it will conduct to that earth, that road also. So what will happen? These charges will start reducing. These charges will not get accumulated and hence our tire will also be saved, as well as our aircraft and many people associated with the aircraft will also be safe. So let's go through the solution. To enable them conduct charges, just we are providing little conduction to the rubber tires to enable them conduct charges. First, where to conduct charges? Throughout the surface of the tire and then from the surface of the tire to the earth. These conducting wheels play a major role in earthing of charges from aircraft and the friction on the tire to earth, okay, produced by friction to the ground. As too much of static electricity accumulated may result in spark and result in fire, okay. These concept number 1 and concept number 2, as far as we know, we have read in chapter 1 itself. In chapter 1 this concept was made clear in chapter 1 in the introduction part itself. Now we will go for the subset C, what they are asking us in the question number C and how we are going to deal with it. Now see, vehicle carrying inflammables material usually have metallic ropes touching the ground during motion. Why so? What are the inflammable materials you think a vehicle can carry? Have you ever seen the petrol trunks? Like they are round in shape and they have written HP or LG or Bharat Petroleum and stay away from fire, the temperature should not exceed this and that. They have written something like that, and these trucks are like this. Now you will say every truck is like this. No, they are little special. First thing, they have a cylindrical container on it, as the liquid contained in cylinder is a better way, like the shape of cylinder is better to deliver the liquid. For water, petrol, diesel, such kind of cylindrical tanks are used. And then we have such metallic ropes hanging from this truck, okay. Why so? Again, the result is same as the the concept is same as the subset 2 we have read. This petroleum flows in this container and keep on having frictional force with each and every molecule and the walls of the cylinder, and it also starts accumulating charge, and due to that this container on the above side will also start accumulating charges. Over here charges will start accumulating. If there is a lot of charges getting accumulated and these charges are not channelized, then there is a chances that it will catch fire. Even a little if we are not little aware about these inflammable materials, they can cause a big hazard, okay. That is a irreversible hazard and can harm many and many people and many resources, okay. So in that case we need to make sure that not even little amount of charge is being stored on the surface of these inflammatory carrying vehicle, and then the charges are coming over here. These ropes helps these charges to move towards the earth, they are hanging up to the earth, okay. They hang from here and are attached with the earth over here, like they keep on having some friction with the earth, some touch with the earth, and they remove all the excess accumulated charge to the earth. So this is also a type of earthing. For the inflammable carrying vehicles, okay. Now we will see the solution, what the solution aim at telling us. To avoid the inflammable material catching fire, metallic ropes are suspended which carry the induced charge and transfer it to the earth via earthing. So here the type of charge induced is induced charge. Here induced charge is a charge which is produced without having the normal physical touch, whereas in this case we have seen the frictional charge production. Here also we have seen frictional charge, okay. Now we will go to the D. subset. See, a bird perches on a bare high line of power and nothing happens to the bird. A man standing on the ground touches the same line and gets fatal shock. Why? So, what the solution says, I'll explain it after we read the solution. Current passes only when there is a difference in potential. When there is a difference in potential, V is different, then only charge will move, current will pass. Okay. Now let's see the whole thing. See, this is our wire having a high voltage wire. Okay. High voltage wire. Now a bird is sitting on it. This bird is sitting on it. Okay, this is not getting any shock. Not getting any shock. So can you explain why? See, charge is coming and going here. But is there any way where this bird can conduct the charge? Is it possible for the bird to conduct charge to anyone? And answer to this question is no, it cannot. Why so? You can see the circuit is incomplete. Here the circuit is incomplete. Circuit is incomplete. How? Because there is no other source or the sink. We have source of the charge, but there is no sink for the charge to go. That's why circuit is incomplete. But now we want to see in the case of a man. This man is standing over here. This man is standing over here and touches this wire. Can a man fly? No, he cannot. So he will be standing on earth. So as soon as he touches, man touches high voltage wire, charge or current from wire comes to man. This man is standing on earth. The charge which is achieved by man from wire goes to earth. So here man behaves as a conducting medium between wire and earth, and hence man gets a fatal electrical shock. Hope you understand this thing. This man is completing the circuit. Circuit is being completed. So from wire to man to earth, whereas wire to bird, and from bird to where? Nowhere. So here the circuit is not completed, hence the bird is not getting any electric shock. Secondly, the biology states that these birds have insulated pads on their paw. Okay, so that's why they do not get, but this is the physics behind a bird not getting the electric shocks. Okay, so go through these concept based questions once again. These are extremely important with respect to your board examination as well as with respect to your various entrance examination. And the concept clearance is not just important for your examination, but it is also important for you to understand the role of physics in your life, which is very much important and efficient. So that's all for today's class. This is the question we have solved. In the next class we will come up with a new topic or a new question. Till the time, have a good day. Bye bye. See you again.